Hello, everyone. Let's start with the last regular talk for today. So we will talk about powering analysis and systems. It will be much more architecture. I will show you some cool, just simple SQL queries, which you can try out also at home. So about me, I'm from Târgu Mureș, working at a company, rea.net, and we are doing interesting projects for the other nations. I am among the top 3 Romanians on the Stack Overflow portal who uses Stack Overflow. Great. Who has 1,000 reputation points? Great. I have more than 100,000 reputation points on Stack Overflow by answering questions for the community. Last year, I've been appointed GDE, Google Developer Expert on cloud technology. This is the equivalent of Java Champion on the cloud technology. And I do also mentoring for the community and for the companies as well. You can follow me on the websites, and let's drill in. So today, we will see how data drives innovation. And in order to address this, we need to express the idea that every company, no matter how far from the tech is actually evolving into a data company. Even a small shop at the corner of the street has data, but they are not leveraging, or who has data, they are not storing everything. They are storing only a piece of it. Probably because they cannot afford it, or they don't want to run clusters and so on. In my session, I will address a solution for these small businesses, but this is not only for small businesses, as the system I will present is petabyte scale. So even if you have a full cluster of servers, you can turn it into. As I mentioned, for a small company, it's important to have access to big data tools without a dedicated team for it. Everyone thinks that big data needs a dedicated team. But usually with the standard knowledge, which is actually a middleware, SQL, complex SQL knowledge, you can address certain big data things. Before getting into stream processing, there is a small step in big data which you can actually leverage on your data and so on. So making analytics accessible to more companies needs these things. So it needs to have deep analytics, large, multi-source, complex, and unstructured data. Be real time. We no longer accept results next week. It should be immediately. It should be petabyte scale and cost effective. Petabyte scale, it might sound huge for some people, but we already have terabytes in our tables, and petabyte is quickly reached when you actually implement a solution to gather data. Cost effective, it means that it should be payable. If it's a terabyte, $20, a petabyte is only $20,000. For a larger company, $20,000 for a petabyte is not a huge amount. Actually, it's a small amount. It should be able to run ad hoc reports without a developer and interactive. It means that you as a developer, you wire in the events, you wire in the data, and an analyst can use their tools in order to directly connect on your data and to do their data wrangling and all the analyst stuff. It should be minimal engineering efforts. It's very important to have these minimal steps in order to reach value. And it should be SQL and JavaScript preferred, because all the developers possess those skills. So Einstein has this kind of thing that it cannot be solved things with the same effort we created them. But there are other solutions for it. And if we move forward, we will see that the legacy systems are having an producers, like web, mobile, and there are some consumers which should be the analysts and the reports in our use case. You will have here probably your current architecture has a web server, it has some CMS, and you run cron jobs, scheduled jobs, and so on, and you basically use only SQL and only cache results, either in memcache or either as a flat table. I see heads moving, so I know that this is what we do every day. But behind the scenes, there are days to insights. Let's see what this means. It means that the cron jobs kicks in minutes. Even a minute delay is considered a delay. So it could be real time. It should be like that. Maybe in order to result a report, you need to aggregate certain data sources. You need to do operations, which actually, just to run, it may run hours. And in order to batch process everything, it may need another hour. It could be even days. The end result is that the analyst who wants some data and to produce a report, it may get that data from the developer in a couple of days. I don't even mention that they need to create a ticket, they need to define the problem, it needs to be approved, the developers start working on gathering data, it needs to be deployed, and then the analyst gets the answer, sorry. This means that it may take even a full week in order to have a small report implemented. So we want to move forward and to see much more modern approach to this. The desired platform should have real-time raw ingestion. It should ask sophisticated queries, not just select and group by. It should be much more bigger there. It should have query performance. We know that big data is not like this, but it should be in a 10-second, it should be in a 1-2 minute answer, not next day. It should be low maintenance. You don't have a team for it. You don't need a DevOps team. You don't have a sysadmin to maintain it, and it should be cost effective as well, because you are not using too many tools. It should be a simple and it should wire in easily. There are a couple of solutions to start with. My use case will be using the Google BigQuery, and our ultimate goal is to store everything which we can and accessible by SQL. So Google BigQuery, it's analytics as a service. It's a data warehouse in the cloud. It's run by Google on the GCP, on the Google Cloud Platform. It has also EU zone and world zone. By managed, it means that when you start using, you only give your credit card details, and you don't need to start servers. You don't need to rent VMs. You don't need to project costs, project storage. It just runs. It's smoothly for you, even if you have 1 gigabyte, even if you have 1 petabyte. It runs smoothly for you. That's actually the very good advantage that it's easy to wire in. It's ridiculously fast. So it means that in a 1-2 minutes, you will get decent response time, even if it's petabyte, even if it's a gigabyte. It has the full SQL 2011 standard, which means that you can all use the fancy stuff of window functions, JSON, Math, Geo, and everything else. It already has the familiar DB structure, and it has this extension of it, so you can have records, you can have nested features. That means that if you store a flat row and you have a multiple product, for example, the row is an order, and you have purchased 10 products, that simple row in a nested structure can hold the product itself. And the whole row is seen as a 1 for it. Integrates with every other Google service. So for example, it's easily to create an Excel Google Sheet in the cloud, and you can join in your query with that sheet. That means that your analyst who wants to, for example, turn a country ID, which is just a number, into a defined countries, it may create a list of countries names that she wants. Or if she wants to map certain IDs or certain shortcuts to a full label, she creates a Google Sheet, it fires in as a join, and it smoothly works. Some developers create a file, CSV, let's name it, or JSON on Google Storage, and they can wire in even as a table in the system. It's managed, it has its cost, it's very cheap. It has the convenience of SQL. It means that you can store 10,000 columns, you can batch load 5 terabytes, it's a big data tool, so you don't need to create small files. You can create one super big JSON nowadays, and you can put it there, and in 2 minutes it's ingested. And here I always get a bit shaked because it provides to define user-defined function in JavaScript language. That means that you can write SQL create function using language of JavaScript. It means that you have all the fancy stuff that JavaScript processing, string, math, natural language processing, inline, of course, in the power of the SQL. It has all the rich functionality of 2011 standard. It's append-only preferred. This means that every big data tool nowadays, it's only considered to append. The document, the DML syntax is available, which means you can run updates, but running updates, it costs you more. So instead of running updates, you are actually preferred to insert new records. Let's take a simple example. On a shop, or on a, let's take much more easier example. On a social media, you update constantly your profile. Every profile update is a new row in the system. This is also called a stream, because you will find how the user started and actually how the user ended up doing something. And you can do micro-optimization between the steps as well, because you have the data available for you. By having append only, the question is, how do I query it? Because it's not a row from a user. From you, I have 200, from him, 2,000, and so on. There are functionalities to access the latest row, even the first and whatever. So whenever I want to query, I always choose the latest row, and I display those profile informations, let's say so. But if I want to see how it evolved, I have the stream of data available. It has day partition tables. This is extremely good and cost effective. You can have tables that for each day it's partitioned. So for today it's one partition, for tomorrow another partition. The cool thing is that if you have a 5-year big span and you are only touching the last month data, you are only paying those records. You are not paying everything else. And actually this is how Google BigQuery manages to be so cheap for us. Of course, if you want to run an aggregate on a 5-year data, you can do it. It doesn't stop you to doing it, but it's much more effective to only target the amount of window that you are interested. And it has all this fancy ACL in order to expose some rows for some data analyst and keep something else hidden for them. So taking from a legacy system, in order to move to cloud, usually we see that we have on-premise something and on-cloud a service. And we need to put something on the premise, which are called pipeline, event router, and so on, which actually forwards data out of the legacy system. And through a data pipeline integration at React.NET, which we use, we have this system. And let's see what this does. So we have here our devices and also the development team. On the next side, we have the analysts. In my use case, it could be even the developer for the report, but it could be another different team. We have different sources for our events, And here, I named front-end platform services. It could be a Drupal module, it could be a Spring module, and so on, which actually naturally exposes some data, which is Drupal-ish or Spring-ish, and so on. It could have event sourcing, which you developer add in the code. You line 2 lines, create a JSON, ship it. Create a JSON, ship it. And it could have metrics, logs, and streaming from the machines. So if you have a cluster of machines, like, for example, you have 5 front ends, and you want to collect logs from all the machine in order into a central location to analyze it further, you have this opportunity. And now you probably realize that all this is in a full system. Everything can be accessible together. So I end up running some query, for example, that I seen something in the log information that had developer to find out that something is low, and I had to match it to a user problem because the user created that problem. Because I had in BigQuery both situations, which users were created in that time frame, and what happened in the log file, I was able to match, and I was able to get sample users to try and reproduce the error. It's extremely cool to do these things when you have everything together. Now, from there, you need in the current system to add an event router. In my example, I use FluentD. It's extremely simple, and I will show you what only 50 lines you need to add. And that's literally all. From there, FluentD is a router. It does multiple things. It does, in my example, it creates a forward of the JSON, let's name it, to a server, which maybe writes to SQL. It creates an archive and puts on cloud storage. And also, it streams to BigQuery. What's the benefit of it? The benefit is that on the cloud storage, I have a big file with all the JSONs as it happened. It's stored there indefinitely. It means that I can replay it next year. Why would I need to replay it? Maybe I change the framework, I upgrade my application to the new version, and I cannot migrate data. But I have it archived. So what I do, I get the big file, and I replay as it happened the information. And it recreates itself. It runs maybe 2 days, a week, or I put 10 nodes behind it. It finishes sooner, but I have this opportunity. Often we are surfaced that developers, we don't have data. We didn't store something. We just calculated and vanish it. When we have the raw data, I can replay it. So if my chief comes in, hey chief, I have this solution, so I will implement for you this solution, which means I could create fields for you tomorrow, and from tomorrow starts to accumulate data. But hey, I have in my calculation and stored a JSON and I can remotorize by rerunning the events and to actually populate the database. Now, of course, the final value is that all the team can use their tools, and we can actually mix internal dashboard with something like Data Studio, and we can build our own reports for that. This is complementary to your current solution. This means that if you add in your current stack a good router, it means that you are open for the cloud, you are open to do this. Only by adding a component and only firing JSON events and inputting to their multiple data sources. Everything else runs the same. So, FluentD, I will present in the following 4 steps how to transform something, how to copy event to multiple outputs, how to store for backup, log purposes, replay, and so on. And BigQuery for the immediate analysis. So in our example, we have a record transformer. We usually need to transform something because the JSON maybe doesn't fit for MySQL. maybe doesn't fit for Cassandra, maybe doesn't fit for Redis, and maybe doesn't fit for a purpose. We are able to transform it. Then we are able to copy to multiple sources. I named here two, file and BigQuery, the same event. Of course, there is a matching type, which is the name of the event, which I come up with. The record transformer is a Ruby syntax, and it does its thing on fly. So it's like a function, an anonymous lambda function, which happens as the event comes in. And we are able to remove keys. If you want to clean up something, we are able to recreate those tools. We are able to create new things. I am able to create direct JSON syntax, to create a substructure JSON in JSON and something, or like a record, or document. I can able to calculate averages based on the data. So simple calculations can be done here. Maybe somebody wants with 4 precision, maybe someone wants with country code formatted to 2 codes or 3 codes and different things for it. The copy is very simple. I name the path and I name the time slice. I can create different files for every 10 minutes or for a day and so on. This is flexible for you. And then BigQuery. Here, of course, you need to add the connector things. So you have the JSON key and the project ID, dataset name. You actually name which is the timestamp field. In your data, you have a timestamp field, and you name it. Then you name the table, and here the table is user, but with this special markup, you are able to slice it into that day partition. So you can name that I want to put that into day partition, for example, as this is happened as it goes. And my favorite is that it ignore unknown values. It means that if I have something else in my JSON which doesn't match the schema, it will simply drop from it. So I'm able to reuse the same JSON for different purposes because it don't complain that you don't have that column, and so on. You get it, as I'm seeing that you get it. Okay, so if we just see at these little pieces, this is all what you need to do in your current system. You install Fluentd, you add these things, and you get this out, 50 lines of code. You don't need to modify your existing application, just these kind of things. Where to use BigQuery? On data that is difficult to process and analyze using traditional database. Maybe you don't have access to JSON functions. Maybe you don't have access to write complex storage procedures with JavaScript language. On exploring unstructured, this is also JSON, because when I structure my BigQuery table, I name the columns, but in the end, I keep a table, a column meta, where I put my JSON. So I have column, and I have a JSON. It's a hybrid structure. And I can quickly pick from JSON different things, and I can use it as it was a column. And if I want to rematerialize into a different table, I have the option to choose 2 columns from here, 5 attributes from the JSON, eventually calculation, and make this a table. I have this opportunity. Not a replacement to traditional DBs. So it doesn't replace Postgres, it doesn't replace NoSQL, and so on. It complements the system. Why it's easy to do this today? Because storage is cheap. We are running the era when the storage is cheap. You can afford to store something at this price. As I mentioned earlier, we can inline libraries. I could inline natural language processing library, and I could use text processing on my string as well in the database itself. It could be useful for streams, as if you have a lot of things with never ends kind of stream, you are able to explore the stream, because often you are placed that you introduce Kafka in your system, but you are not able to explore it just by writing an algorithm to it. But if you feed the same data to BigQuery, even if it's in Kafka, stays there until it's processed, but in the BigQuery, you are able to get a sample of it. you get the full data, but in order to get yourself developer a sample, you are able to run a select for it. Okay, let's tell some use cases from our experiences. So the first one is optimize product pages. Here we are using time-consuming problem. We are identifying time-consuming problem. Let's name a shop where you have a sign-up form or you need to pick country from a huge select dropdown. And I mentioned that every save is a new entry in our database. You will eventually find out that choosing country takes 7 seconds. And you would try why. It's hard to scroll on the list, and you want to optimize it. How do you optimize it? Prefill, pre-select with based on IP, put the most used countries at the beginning of the select, and so on. You gain 7 seconds from the user to do something else, to reach farther the product and so on. Of course, why would this would be possible? Because you have append only and you have append preferred, and you have all the raw data the user did for you. And you had the data to come up with this. Otherwise, you specifically need to implement this data collection. Of course, you will end up that you mimic Google Analytics inclusion, but Google Analytics doesn't have people. It has only visits. You cannot name that Adam did that, and so on. You only see basic numbers there. But if you are able to have all the hits also in BigQuery stored, that would be awesome. Now, here you can do it yourself, or you could export it from Analytics. There are packages in Google Cloud Platform where you can get access to the Analytics raw data for your project using BigQuery. It's for big advertising agencies, and you should try it and see it if you are interested. It has an expensive price, like $150,000 per year license. But for a big agency who has, I don't know, millions of revenue, $150,000 to get it gets. So this is not for simple companies, but it's possible. So they are offering as an enterprise product to get raw access to the analytics part. And you are able to join what you see in analytics to the relevant database of you. You are able to identify people and so on. Email engagement. Usually create a template, send it. You never track what they do. But we are able to track the open, the click, and so on. You are able to actually have every clickable element in an email having a dedicated link. That dedicated link, when it's accessed, it submits data into the database. And then you are able to come up which buttons they actually press and look, and what are the different time sections, like 5 seconds, they spend 20 seconds, they click 7 times the template, and so on. And actually here, the A/B testing is the gold thing to do. As you can, if you have this kind of feedback, you can do A/B tests. Like for that group, I'm sending at 9 a.m. the email, or for that group at 8 p.m. And later I find out that I have for individual users that you are opening at 9 a.m., you are opening at 10 a.m. And I could send the email 5 minutes before his habit. And I have first inbox placement for it, only if you have the data available. Funnel analysis. This comes back to Google Analytics type of thing, that storing hits means that later I can do funnel analysis. I can see where the user navigated. I can add ad hoc, which ad hoc means that not just what Google Analytics let me build and they figure out. I can select certain pages, like I want a specific article page and a specific order, which may be the visit 500, it may be the visit 3000. And I want to see what happened before, or I want to interconnect. I will show you some example for this. BigQuery has a public data set. You can try it at home. You can feel it, how it's working with it. It has huge data sets, and without charging you. So the first terabyte of query for you is free every month. So you can go there, open a project, and you can try out different sample queries. They are there. You can Google it for the sample queries, and you can write your own. One example of the public data set is that there is this weather information, and I wrote a query to find out how many days we record snow in our mountains. You may have known this, but it's okay. Okay. I will show you later this. Achievements. So I was talking about funnel analysis. Let's see how this practically in practice works. So I need to build a larger, longer query, which first I will explain here. So I need to identify a session identifier, which is the user or a cookie or whatever. Then I need to name my sign-in page, and then all my other pages, and I need to link it together. This means that this is reduced here. So all the heart of the system is that I am finding the event sign-in, and I name it step 1. Then I do the same thing in line here with the step 2. But the step 2, the join condition is that it has the same session ID, and also that step 2 happened after step 1, and so on. Step 3 happened after step 2, and I end up with a table like this, only from the storing individual hits. Something more complex. I already mentioned that I may want to attribute a credit, like a referral system, to a platform, and I made this ad on the go to it. So I didn't build an affiliate system around it. What I do here is that I have the hits of the users, and I need to identify the first order. And then I need to identify the first article. So the user may have multiple articles visited from my affiliate partner and multiple orders placed from it. And I want to attribute credit to it. So here as well, it's a simplified query. I am doing a numbering. So in order to know which is the first, which is the second, I need to use a window function based on that user. So I'm sending only the user's accesses, and I need to number it, 1, 2, 3, and so on. This is done by the help of row number and window function. It's ordered by hit time. It's partitioned by the user, and I name it hit index. Later, from this, I'm checking which, with regular expression, my pages. I explained here with regular expression. In my last example, it was an equal part. Then I'm picking the first one. So I'm able to pick the first one. This could be the last one, it could be the third one, the first one, and so on. And when I have the first one, I can do the same with the first page orders. So this thing here is a view which has this kind of logic. So I'm numbering again the hits, I'm filtering for the orders, and I'm picking the first one, or I'm picking the last one. So it might end as a long query, like a 200 lines or 300 lines, but it does its thing. Why it does its thing? Because it's BigQuery. If you would run this on Postgres or MySQL, it may run for hours or even crash your servers building indexes and swap and so on. But on BigQuery, depends how big your data is, between 10 seconds and 2 minutes, you will have your data. If you run this on Spark or Hadoop and something, you may end up that you implement something, you start the system, it runs for hours, you look at the logs, heap out of space. You Google it, Stack Overflow. I see people smiling, so this happened for you. You Google it, Stack Overflow, you tune some configuration parameter, you run it again. It runs 8 hours, but it doesn't produce you the thing that you want, and so on. So with the CQL, you have access to certain functionality. When you validated the data science idea, like a startup validates, You are able to build a solution, for example, on Spark or on Hadoop and so on. But that means that the initial event is also stored in BigQuery and in other systems as well. But you are able to quickly move around with this idea of having your data available there. And you can choose what I display from MySQL, what I display from BigQuery, what I add to stream processing, and so on. The email thing I mentioned, you are able to use a heat map. So the heat map, as you know, it has its colors, but on an email you cannot get the coordinate of the mouse. You only get the clickable elements. And you are able to come up with a table that position 2 of a link, it may have this number of counts. And you are able to use this and leverage marketing from it. What else? Normally with the email, that's the first marketing tool usually. You can do spam checks, ESP deferrals. For example, Romanians have still a lot of Yahoo accounts, and Yahoo defers a lot of email when you are sending out campaigns. You're able to see it on the system. You are able to retract from the queue. If you are able that Yahoo is refusing your connection, you can take a pause and so on. You can do content A/B split tests with the metrics, like positioning this button here, there, have a nice hero image, it should be blue or orange, and so on. You could have a trend or an open rate campaign, like you would immediately see that this campaign is working or not. You launch it, you see how many accesses you have it. You can, of course, engage users. Like I mentioned, I find out that Marton opens emails at 9 a.m. I send it 5 minutes earlier. It's first inbox placement. Win. Our benefits: no provisioning, no deploy, no running out of resources, no more focus on large execution pan, no need to re-implement tricky concepts like time windows, join streams. I usually just join on a session variable, which is defined. I can run ad hoc queries. My analysts can run their tools without producing them something column-based. And I no longer throw away expiring, aggregating all data. I can store the granular data, not some average, daily average, and so on. BigQuery is serverless. Like I mentioned, you don't need to create sharding. You don't need to guess the capacity. It doesn't have idle resources. It means that you are not paying for machine if you don't use it, for example. It doesn't have maintenance windows. You don't need to stop it for the deploy process to update something. It doesn't have manual screens and no file management. So you are not running out of disk space. For example, if you have a 4 terabyte hard drive and your data is bigger than that, you need to transfer it. And this actually managed services mean nowadays. So it's everything taken away from you. The Google engineers are doing it for you, and you are actually just paying the consuming services. You could use Data Studio, which is another cloud platform, which you are able to create a sample dashboard like in the image. And here everything is backed up by SQL. So every piece of table, every piece of metric, all those metrics have in the background the SQL. Normally, I get a question like how many SQLs are in this dashboard. There are like 60 SQLs written for this dashboard, but if you want to create such in a system, you need to write those SQLs as well. And you are able to filter it interactively with that, and you are able to be like a Jedi with the data as well. Okay, let's run some examples. What's the time? I'm not seeing here. Good. Okay, I have this one here. So I want you to show an inline JavaScript user-defined function. You know select, how to write select. It's the select wrapped in a JSON function, and I'm outputting services column from it. This is just a minimal example. I define my function. This is a header name. I'm using a different function here, which gets the row, and it has an output parameter emit. Now, with emit, I can do multiple things, and this is actually a logic here, because when you get one row input, you can emit nothing, you can emit one row, you can emit 3 rows. And this is add flexibility, because in SQL, when you do a join, how do you emit 0? You filter it with the group condition. You are emitting somewhere something 0, which is filtered. How do you emit 1? It's actually the join. But how do you emit multiple things? You cannot expand. You need to join itself, and so on. So with this emitting, I can emit from 1 row, 3 rows. And it could be different columns. So I could use an algorithm to change the columns and to emit in different thing. Now, from the row, I'm using JavaScript from now on. It's no longer SQL. The row has a meta attribute, which is JSON. I need to parse it. It gets created as an object variable. Then, from the object structure, this is a structure, so I go to container, which is the first key. I go to the next key, services, which is plural. And for each, this is an array, as mentioned, it's a plural. I am running a function which is actually emits the services from it. So this means that I had a row where I had a JSON stored, and somewhere in JSON I have an array, and from there I am emitting all the occurrences to it. In the end, I get a table output multiplied. The rows, as I see in the beginning, it's multiplied, but on each row I see different services emitted. And to see how it goes, so normally it has a header like a function. It's here, which is called there, and I can run edit and run query. This gets processed, let's see. So it processed 3 gigabytes, it took that much, and I'm emitting this. This is just for the sake of example. There are other columns as well. It's there. Questions on this one? Now. Okay, we will have questions at the end of the session, and I can come back. Oh, where it goes. Okay, I need to not delete. I want to close it. Okay, let me show you a much more bigger example. Using create function, not inline. I'm able to create a function. I name the structure and so on. In the end, I have this language. Oh, it jammed. Do you see in the back? So I have this language JavaScript, and I can, from there, start to do things. So I need to run this in order to be self-explanatory, what I do here. Let's go. And why it's not, okay. So this was my input thing. It was a string, and I had to split into variables. It's self-explanatory when you see what it happened. So the 55 got in its own column, the 12 in its own column, and so on. What I did is plain JavaScript splits and so on. But here, the imagination can add you anything. You can add semantics to it, and so on. And here, with the JavaScript, you can inline semantic analytics, natural language processing as well. Okay. Again, I did. I show you the snow. Now, a public example. So if you want to try out BigQuery, there is the full Reddit on BigQuery. Yeah, that cool is. So the full Reddit is available for you to query on BigQuery, and Stack Overflow and open source GitHub as well. I will tell you a cool example for that. And you are able to research Reddit. For example, in this, I'm searching these subreddits, which is startup entrepreneur productivity, for books. How many times books are recommended? I define books by a regular expression, by a link to the Amazon.com book reference. And screen is small. So I came up with this, of course there is a count. I came up with a count that which book, how many times is referenced in the Reddit as well. And my cool example. A guy, I don't know from which big company, found out a memory leak issue in a big tutorial. I don't know even the language, if it was Python, JavaScript, I don't know. He then wanted to research how many projects are using that line wrong based on the tutorial. On GitHub, what he did, he wrote to BigQuery, he wrote a query that actually had referenced that line of code in GitHub. Why was this possible? Because all the GitHub open source, not private, open source projects are available as a table, as a data set in BigQuery. And he was able to identify like 2,000 projects. And then he was able to give it the test to someone else and wrote a marketing team, wrote a message for them that, hey, you should fix that because it gives memory leaking. He did bug fixing for the community as well. Good, and one more example. Okay, I need to close this. So, let's see the power. So, before running this, it's really cool. There is this GDELT database, which is another big project, not of us, it's open, and it adds semantics to the articles, to the media coverage. So they actually monitor the media coverage and they add semantics. Like they add semantics like person, and we end up calculating how many mentions of Johannes, Dragna, and so on we had in the news coverage. If you run this before elections, and if it's not a closed number, like it's a different number, you are able to actually predict elections, because nowadays people elect by the number of news they're hearing and the number of things. You could enrich this data with the sentiment, like positive, negative, and so on. Just by running a query on BigQuery with the GDELT database available to you. So let's see the outcome. So it processed 4 gigabit of data. It took 4 seconds, and if it would let me the page, but it doesn't let me, so I will zoom in. So the mention, Johannes is still mentioned a lot than Dragna. In the articles, in the media coverage, they are monitoring because they probably don't monitor RTV and other, I don't know the name for those news coverage. They only monitor the true ones. And of course there is data is that there are others mentioned in the articles as well, but you are seeing this. And if you go forward, we are able to find her, we are able to find this man, and so on. We are in Transylvania. I don't need to tell you what these results mean. Okay, so this concludes my talk. You can find the presentation shortly, but the previous version is already on the SlideShare. We are from Târgu Mureș. We are doing sort of big data, as you've seen, on large data. And see you at the next conferences. Thank you. Questions? Yeah.
Could you explain a bit more about the cost? I feel that storage is cheap, but if I then have a dashboard with lots of SQL queries for the marketing department, they click on it every day,
Yeah, so I ran a simulation. I didn't include the presentation because it would be too rude to include costs comparison for that. Google Cloud offers this calculator. Where is the calculator? Pricing calculator. So I know a number that around 70 query, storage. Let's use 100. No, it's too much. Let's be realistic. 50 terabytes. Okay, I think that's realistic for us. Streaming inserts. How many inserts we have in a month? Let me 5 terabytes. So we already have 50 terabytes stored from the previous months, and we are adding 5 terabytes a month. And we are querying, let's say, the double of the storage. Because query is usually more than 1 storage. So let's use 5 terabytes to estimate. So the estimate is this, for 50 terabytes. Imagine this for a couple of gigabytes. I can zoom in, sorry. So it's, let's say, $2,000, even if there is network and so on, which is usually not in these calculators. They charge the ingest and so on, which is a small fraction. For 50 terabytes, this is. And if I lower the numbers, it should be, let's see realistically, because not, change my, let's change this to 10 terabytes. Streaming inserts, I can leave it. And let's change this to 5, or 10 to take out to 0. So I'm halving this. And even with 10 terabytes of storage, it's $700 for 10 terabytes of database, and actually you need, I think, like 15 machines in order to get this to this throughput and so on. And I don't name also the disks that you need for it. I ran a calculation, one petabyte, which is a magic number, it's $21,000. So affordable for a big company. For you, the first terabyte as a newcomer, as a trial user, it's free every month. You can try it out. You can run one single query that consumes that 1 terabyte. So it should not be surprising to you, because if the data is large and you run a query, in a query you can consume that 1 terabyte. That's it. Next question.
What is the amount of data that is coming back for its scan?
So yeah, it's they name it like, so you are paying the storage, you are paying the columns that you access. Yeah, and here I have another story. Why was the app-only preferred? Why was the cost made to name the columns? Because people have this habit to only do updates. We need to force some of them to the app-only technology. Leads to better insights. And people tend to use select star, select everything. We need to force them to use select columns. And that's why they do that. If you do select everything, normally you eat the terabytes table in a one-shot query. But if you select certain columns from it, it gets only a fraction of it. In my example, if I name that I have lots of columns and I have a full JSON column, if I access the JSON column, that's costly, because the JSON is usually 100 kilobytes data in its own. A value like a country ID is just 4 bytes. And so on. So normally it has its price when you access some large structure. But you can postpone it. And the other good thing is that every query creates a table. And you can reuse that table. So from a big data set, you run a query, and from there you are selecting the end resulting table. And you can choose that and so on. So smaller data sets.
So simple select count from a table is
Select count from a table, that's meta information because you are not touching the column, so you are counting. But if you select average of total amount, the cost would be all the bytes of that average column or the revenue, not from the table. You have 1,000 columns, you are totaling the revenue, and only that column is your cost. Next. Yeah.
Is there a possibility to migrate? Excuse me. Is there a possibility to migrate your existing data from local DB to BigQuery?
If it's CSV compatible or you can produce CSV outputs, yes. If you can produce JSON outputs, even better, because with JSON you can from start produce nested things, which is much more suitable for this thing. There are commercial solutions which offer you plugins like viral listings, but I wouldn't put that at hand because this market changes very fragmented. Your application changes and then it needs to change the other side. So you need to add it to the application itself first to gather this data, and when you are happy with it, then you do the application. But if you produce JSON files as big as 5 terabytes, you can simply need one job. I could show you 2 lines and ingest 5 terabytes in a minute. Next. Okay, thank you very much. I'm here for next questions. Thank you very much.